Hey guys, IE.RBT here, and we're looking at Module 5, Homework B, Tab 2, Part 3, which is Parallel Capacitors-Charges. So this is pretty similar to the other question because I explained it more with the algebra in the last question, or the last part, sorry. So pretty much in a parallel configuration, all the capacitors are connected across the same voltage source. This means that the voltage V across each capacitor is going to be the same, right? So the charge Q stored in a capacitor is going to be given by the equation Q is equal to C times V, where Q is charge stored in capacitors, C is capacitance, and V is the voltage across the capacitor. So now we can go ahead and apply the formula to each capacitor in the circuit. So it feels a little bit repetitive considering I just did this like less than 30 seconds ago. But for capacitor 1, it's going to be Q1 is equal to C1 times V. And then for capacitor 2, it's going to be Q2 is equal to C2 times V. And then for capacitor 3, it's going to be Q3 is equal to C3 times by V. And that's pretty much it. That's what you're going to go ahead and put into Snape physics. It's a pretty simple question. And it's important to know that in parallel circuit, each capacitor is directly connected to the voltage source. This means that they all experience the same voltage V, leading to individual charges proportional to their capacitances. And the capacitance of a capacitor determines how much charge it can store per unit of voltage. A larger capacitance means that the capacitor can store more charge at the same voltage, and the total charge in the circuit is distributed among the capacitors based on their capacitances. Each capacitor will have a different charge, and this reflects its ability to store charge under the applied voltage. And I hope this helped.